Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In the previous sessions, we talked about time series analysis, various types of index numbers, statistical quality control and control charts. As part of the study of control charts, there are 2 types of control charts called control charts for variables and control charts for attributes. In the previous session, we just talked about control charts for attributes are P chart, NP chart and C chart. In this session, we are going to work out some more examples in control charts for attributes to understand the concept further. So, first to see the example goes like 20 samples each of size 10 were inspected. The number of defectives detected in each of them is given below. That is, each sample is consisting of 10 items. Among 10 items, there will be 1 defective or 2 defectives or no defective at all. But the number of samples inspected is 20 samples are inspected. For example, sample number 1 gives no defective, and similarly sample number 2 is giving 1 defective out of 10. Similarly, sample number 3 is giving 0 defective out of 10 items. Last one, the 20th sample shows no defective out of 10 items in that particular sample. The question is, construct the number of defectives chart, that is NP chart, and establish quality standard for the future also. That is, if there are particular points which are lying outside the control limits, then we will delete them and then we will again find out the control limits, 3 sigma limits as revised one. That is, revised UCL and revised LCL will be calculated so that we will be able to establish the quality standard for the future. This is done in this example. Here we have samples of a fixed size n is equal to 10. The total number of defectives in all the 20 samples is summation D is equal to 0 plus 1 plus this number of defective values 0 plus 1 plus 0 plus 3 plus etc. It goes up to 2 plus 1 plus 0, and the value comes to be equal to 31. So, an estimate of the fraction defective is done, that is P bar is summation D divided by n into k, and here there are 20 samples each of size 10, therefore n is equal to 10 and k is equal to 20. So, summation D is 31 into 10 into 20, and the value is 0.155. So, P bar value is 0.155 and Q bar is 1 minus P bar is 0.845. It is 1 minus 0.155. Now, next we have to calculate 3 sigma control limits. the CL for the number of defectives is n p bar, which is n is 10 into 0.155 is equal to 1.55. So, CL of NP is 1.55, UCL of NP is n p bar plus 3 into root of n p bar into q bar or 1 minus p bar, and n p bar is 1.55 plus 3 into 10 into 0.155 into 0.845. This is 1.55 plus 3.43, which is equal to 4.98. So, UCL of NP is 4.98. Next, LCL of NP is n p bar minus 3 times root of n p bar q bar. Q bar is 1 minus p bar. So, n p bar is 1.55 minus 3 into root of n is 10, 0.155 into 0.845. Okay, and the value is coming to be negative, therefore, we take the value as 0 because of negative values are not allowed. Okay, so, LCL of NP is 0. Okay. Now, the control chart is drawn here. This is NP chart. X axis is showing the sample number and y axis is showing the number of defectives. Since there are 20 samples, we will have the sample number starting from 1 to 20 and the number of defectives are 0, 3, etc. Therefore, it is drawn on the y axis. Okay, let us see how the values are plotted. Okay. So, first of all, for example, first let me plot the number of defectives. For sample 1, the number of defectives is 0, and for sample 2, the number of defectives 1. So, this orange dots shows the number of defectives, being plotted on the graph sheet. Okay. Similarly, next these orange points. So, 20 values are plotted in the sheet. Then we draw the UCL of NP. UCL of NP is equal to 4.98 and it is drawn just below 5, and 4.98 is actually rounded off to 5 and it is drawn. This is UCL of NP is 4.98, and then this particular line here is LCL, that is LCL of NP is equal to 0. Okay. Then CL, control line CL of NP. What is CL of NP? We have calculated, it is 1.55. This is CL of NP is equal to 1.55. It is drawn with the points are plotted with the green, and then the line drawn here is CL of NP is 1.55. Okay. So, the values are plotted and the lines, 3 lines are drawn. First of all, green points with the maroon line, it is here, it is CL 1.55, and this value blue line, dark blue line is 4.98 is UCL, and this is 0 and LCL. Okay. After seeing these 3 lines, particularly this particular line and this one and this one, and seeing the sample points, we see there are 2 points which are lying outside the control limit. There are 2 points which are lying outside the control limit. Just see. Now, since the 2 points corresponding to 5th and 8th samples, isn't it? Corresponding to 5th and 8th sample are lying outside the control limits, we conclude that the process is not in a state of statistical control. No, to establish the quality standards for the future, we eliminate these 2 points. when we eliminate the 2 points from 20 points, there are only 18 samples are taken into account. It means that is we are eliminating the 5th sample and 8th sample. So, out of 20 samples and 5th and 8th samples are eliminated, we have only 18 samples. So, deleting sample numbers 5 and 8, we compute CL, UCL and LCL based on the remaining 18 samples as follows. Revised control limits for the future is P bar is equal to summation D minus the 8th corresponding number of defectives in the question is first of all 5th corresponding value is 9 and the 8th corresponding value is 7, and we have got summation D, the whole number of defective summation as 31. So, 31 minus 9 minus 7 will give you the number of defectives total for the remaining 18 samples. So, summation D minus 5th and 8th NP value is deducted divided by NK. So, that is 31 minus 5th NP value is 9 minus 7 divided by number of items in each sample is 10, that is not disturbed, number of samples is disturbed, therefore, out of 20 we have only 18. Okay. So, that is we have 15 divided by 180 and P bar dash value comes to be equal to 0.083. Now, next CL of NP bar dash, this is since it is new, we will have a CL as NP dash is P dash bar, which is equal to N P dash bar is equal to N is 10 and 0.083. So, CL of NP dash is equal to 0.83. Next, revised LCL and revised UCL will be calculated. So, UCL of NP dash is equal to NP dash bar plus 3 into root of N P dash into 1 minus P dash, which is equal to 0.83 plus 3 into root of N is 10 into 0.083 into 1 minus 0.083. P dash is 0.083, 1 minus 0.083, and the value comes to be equal to 0.83 plus 2.62, which is equal to 3.45. So, the revised UCL is 3.45. Okay. Similarly, LCL of NP dash will be 0.83 minus 2.62, which is a negative answer. Therefore, we take LCL of NP dash is equal to 0. Now, let us see the graph again, and the revised UCL, revised LCL and revised CL is again drawn, and the revised LCL of NP dash is also 0. So, that is drawn here, and this is the revised UCL and this value is 3.45, isn't it? And revised CL is 0.83, this one. Okay. I will just put an into for the revised lines. Now, you can see all the sample points that with orange dots are just lying between LCL and UCL. No orange point is seen outside UCL or revised UCL. Okay. So, this is a revised upper limit UCL, and this is also revised central line, and this is revised LCL. Okay. Now, we see no sample values other than those which have been deleted fall outside the new limits. Now we take these new limits along with the new central line as standards for controlling the product in the future. The next example is number of defectives for varying sample sizes. In the previous problem, we have seen the number of defectives for the samples of a same size. Here the sample size differs with the number of defectives and with the sample numbers. Okay. So, the following data give the number of defectives in 10 independent samples. Number of samples given is 10. So, k is equal to 10. We have to be very careful when we are dealing with the n values and k values. K represents number of samples and n represent number of items in each sample. Okay. So, 10 independent samples of varying sizes. So, k is equal to 10 and varying sizes means according to sample number the n values will be n1, n2, n3 etc. Okay. From a production process. Sample number 1 is having 2000 items in, and the number of defectives out of 2000 items is 425. Okay. Similarly, for sample number 2, the number of items is 1500, out of 1500 the number of defectives is 430. Similarly, for the 10th sample, the number of items in the 10th sample is 1575 and the number of defectives is 305. So, the question is draw the control chart for fraction defective and comment on it. Solution. Since we have various sample sizes, we have variable control limits also. So, UCL and LCL will be calculated for each sample. Okay. Since we have a variable sample size, we can draw the control chart for fraction defective in following 3 ways. So, first of all, a variable control limits. The formula is UCL is equal to P bar plus 3 into root of P bar Q bar by N I. Similarly, LCL is equal to P bar minus 3 into root of P bar Q bar by N I. Okay. Where P bar is equal to summation D I by summation N I. This is number of defectives given is D value, and this total comes to be equal to this summation D I N I values. Summation D I is 3187 and summation N I is equal to 17790. That is the total of 2000, 1500 starting from 2000 to 1575, and summation D I is the total of 425 to 305. Okay. Summation D I is 425, 430 and the total comes to be equal to 3187. So, 3187 divided by 17790 and the answer comes to be equal to 0.1791. This is P bar value. Okay. Thus, Q bar is equal to 1 minus P bar, which is 1 minus 0.1791 is equal to 0.8209. This is Q bar. Okay. Now, P bar Q bar, because that is also required here, P bar Q bar value is 0.1791 into 0.8209 is equal to 0.1470231. This is a P bar Q bar value. Okay. So that we calculate in the tabular column each and every value. Just look at the tabular column. This is this P bar value, P bar Q bar by N. This value is P bar is 0.0000735 if divided by Ni. Similarly, for this value 0.000098 is actually 0.1791 into 0.8209 divided by 1500. Okay. So, like that the values are calculated, and the square root of P bar Q bar by Ni. Okay. That is the square root of 0.0000735 is 0.008573. Similarly, the square root of 0.000098 is 0.009899. If you want the third value also is 0.000105 square root is 0.010247. Then this value is 3 times root of P bar Q bar by Ni. Okay. That is 0.008573 into 3 value is 0.025719. Okay. Similarly, 3 times 0.009899 is 0.029698. Likewise, you have calculated the value, then UCL is P bar plus 3 times root of P bar Q bar by Ni. That is P bar value is 0.2125 plus 0.025719 value is 0.205. Similarly, LCL value is P bar minus 3 into root of P bar Q bar by Ni. So, likewise the variable U bar values are calculated, and the variable UCL are calculated. Similarly, variable LCL are calculated, and all the values are going to be plotted in the chart shown. Okay. Now, the sample numbers is from 0 to 10. This dark blue points are the dots are the exact number of defectives, exact fraction defective P bar values, isn't it? So, for the sample number 1, the P bar value is for sample number 1, the P bar value is 0.2125. So, this value is 0.2125. This is P. P is equal to Di by Ni, and this value is 425 by 2000 and 430 by 1500. Likewise, for sample 2, it is 0.2867. Likewise, as for sample 3, it is 0.1543. So, these are all fraction defectives, fraction defective. Then UCL for sample 1 is 0.205. This value is 0.205, and similarly second value is 0.209 corresponding to sample number 2, and this value is 0.210. Likewise, the values are written, and similarly this is also 0.210, and this is UCL. LCL is this. LCL for the first sample is 0.153, and similarly 0.149, 0.148, again 0.148, 0.147, 0.152, 0.153, 0.153, 0.159 and 0.150. Okay. UCL values 0.212, 0.207, 0.206, 0.205, 0.2 and 0.208. Okay. Likewise, variable UCL and LCL are calculated. Now, the interpretation from this data is in the given data you can see corresponding to sample 1, 2 and 4, the values are called high spots, isn't it? Corresponding to 4, the value is 0.2526, isn't it? 0.2526, and also you can see there are another 2 points lying outside LCL, that is corresponding to 7 and then corresponding to 9, the fraction defective is 0.1078, somewhere here 0.1078. Okay. So, we can see the values which are lying outside the control limits are 5 values. 5 values are lying outside the control limit, and this suggests the presence of assignable causes of variations, and these 5 values, if they are deleted or eliminated, then we will say the process is under control. In this session, we have worked out an example in calculating the UCL, LCL and CL for a number of defectives. So, we have also drawn 2 NP charts, and then we have calculated the revised control limits, so that the points which were lying outside the control limits were eliminated, and then the process was brought to control after eliminating the points. So, the one example was worked out with the constant UCL, LCL and CL values, and another example was worked out with the variable UCL, LCL values. The following question may be posed, that is, construct the appropriate chart for the following data. Sample number has been given from 1 to 22, and each sample consists of 200 items. Sample number 1 200 items, similarly sample number 2 is 22 is 200 items. So, number of defectives out of 200 items is 3, 1, 0 respectively starting, and 2, 3, 1 respectively. So, what can be concluded about the behavior of the process? That is, whether the process can be considered as statistical quality or not. That has to be done here. Thank you.